Hello grade 11s. In today's lesson we're going to be looking at vectors in 2D, approaching exam type questions. And let's get into the lesson. In question 2 we have two forces of magnitude 50n and 80n act at a point on a Cartesian plane in the direction shown in the sketch below. Now we can see that our 50n is acted at an angle of 30 degrees and our 80n is just horizontal like that. Now 2.1 says give the correct term for the following description. A single vector having the same effect as two or more vectors together. We already know what that is. That's resultant vector. Right. Now 2.2 says calculate the magnitude of the vertical component of the 50 Newton. Now you have to note they said the vertical component. So it's very crucial that you read your statements correctly. Now for your vertical component, you'll remember I said you use the formula Fy is equals to F sine theta. Now the force that is acted at an angle there is 50, right? So they're saying magnitude of the vertical component of the 50 Newton. Come here, you put your 50 and then sine 30 degrees. Punch that in your calculator, it gives you 25 newtons. Right. Now 2.2.2 says calculate the magnitude of the resultant or the net force, right? So how are we gonna calculate the net force? We need to also calculate the horizontal component of the 50n. So the first thing we're gonna do is try to resolve this into a vector diagram. So we have the 80 Newton here. It's horizontal like that. But then when we resolve this one, we say in terms of your horizontal movement, where is it going? It's going to the left. So that's your Fx. In terms of your vertical movement, where is it going? It's going upward. So that's your Fy. So resolving that one, you will have Fx here. No Fy there. Fy there and Fx here. So vertical component, horizontal component. Now we need to calculate the horizontal component. The vertical component, we have calculated it to be 25 newtons. Now we're only left with the horizontal component. So for horizontal component, you'll remember I said Fx is equal to F cos theta. Now you have your 50 cos 30 degrees. That will give you 43.30 Newton. Then you just plug it here. Now that you have your vector diagram here, you need to now get the resultant of the horizontal forces and the resultant of the vertical forces. With the vertical forces, you can see that we only have one force here. So this becomes the resultant of the vertical forces. But with the horizontal forces, we have two forces that are obviously acting in opposite directions. So what do we do here? We choose the positive direction. So let's choose this one as the positive direction, and this one will have to be the negative direction. So since they are acting in opposite directions, they have to subtract. So this is how we write it. We say sum of the resultant of horizontal forces, that's 80 plus negative 43.30. Remember, this one is going in the opposite direction. So that becomes, if you punch that in your calculator, you say 80 minus 43.30, that's 36.70 Newton. And that's the resultant of the horizontal forces. The resultant of the vertical forces, it's only the 25 Newton. So where is this one going? It's going to the right. And where is this going? Upwards. Before we calculate the resultant of the forces, let's try to draw a vector diagram just to see how these forces will look like. So this is your Fy, the sum of Fy, which is 25 Newton. It's going upward. And this is the sum of Fx, which is now 86.7 Newton, and it's going to the right. Now, if you are looking for your resultant, you have to close off this diagram. It becomes a right angle triangle, and then now you have 90 degrees there. Now you're looking for your resultant force, or your F net, as the hypotenuse of these two sides. So let's try to erase here. Now with that, we can now say F res is equals to Fx squared plus Fy squared. Now for your Fx, we have 36.70 square. Then for your Fy, we have 25 degrees. Now if you punch that in your calculator, you have 36.70 square plus 25 square. That gives us 44.41 newtons. And that's your resultant force. So we say tan theta, remember it's Fy over Fx. So if we have our right angle triangle here, this is our Fy, this is our Fx, theta here. So we take opposite over adjacent. Then what is our Fy? 25. Our Fx, it was 36.70. Now for your angle is theta tan 25 over 36.70. Then punch that in your calculator. We have our theta is 34.26 degrees. And that's how you solve this question. X, Y, and Z of magnitudes 200, 450 Newton, and 350 respectively act at a point X in the direction shown below. The forces are not drawn to scale. Now 2.1.1 says define resultant force. This is a single force or a single vector that has the same effect as two or more other forces added together, or two or more other vectors added together. Now for 2.1.2, it says calculate the magnitude of the resultant force of these three forces. Again, we're going to do the same thing that we did with the previous question. So first, we want to try and draw a force diagram just to see what's going on here. So we have 200. For Z, we have 350 Newton. But remember, Y is acted at an angle, so we need to resolve the forces. In terms of your horizontal movement, where is it going? It's going to the right, so that's Fx. In terms of your vertical movement, where is it going? It's going upward, so that's your Fy. Right. Now we need to calculate the magnitudes of your components, the Fx and Fy. Now we have to use this force here, 450 Newton. So starting off with Fx, we have Fx, again it's F cos theta. And the magnitude of the force is 450. Then that's cos. What's the angle that we've been given there? 60 degrees. So cos 60 degrees. You punch that in your calculator. It gives us 225 newtons. To which direction? Right. Now let's calculate Fy. For Fy, you have F sine theta. Then again, it's 450, but this time it's sine 60 degrees. Also punch that in your calculator. That's 389.71 Newton. And where is it going? Upwards. Nice. Now that we have Fx and Fy, can come to this diagram and just plug it in here. This is 389.71 and Fx is 225 newtons. Now we need to get the resultant of your horizontal forces and the resultant of your vertical forces. Now you can see that the horizontal forces are acting in opposite directions. So the 200N is to the left and 225 is to the right. So that means we need to choose one as a positive direction and the other as the negative direction. So we follow the number line as it is, positive on the right, negative on the left. Also for the vertical forces, the same thing is taking place. So we have one acting upward and one acting downward. So upward, positive, downward, negative. Now that we have the forces acting in opposite directions, that means they have to do what? Subtract. Now for the sum of the horizontal forces, we have 225 plus negative 200. Then that's going to give us 25 Newton. But for the sum of the vertical forces, we have 389.71 plus negative 350. Now let's punch that in our calculator. 389.71 minus 350, that's 39.71 Newton. Now that we have the sum of the horizontal forces and the sum of the vertical forces, we can get the resultant force. So for the resultant force, we go F net is equals to Fx square plus Fy square. Now what did we get for our Fx? It was 25 newtons, and for Fy, 39.71 newtons. So square, 25 square plus 39.71 square. Punch that in your calculator. Now we have 46.92 newtons. And that's your resultant force. Now let's look at the third one. It says two forces A and B of magnitudes 500N and 300N respectively act on a point O in the directions shown below. The forces act on the same plane and are not drawn to scale. Now 2.1.1 says, define resultant force. Again, what is your resultant force? A single force that has the same effect as two or more other forces added together. 2.1.2 says calculate the magnitude of the resultant force. Again, we want to resolve this and see what's happening. So we have B here. That's 300 Newton. But we can see A is acted at an angle. But what is wrong with this angle? It's moving all the way from the y-axis to the hypotenuse. Remember I said our angle must always move from the x-axis to the hypotenuse. Now that means we won't be using this 125. We need this angle x here, which is from the x-axis to the point A. Now that means we have, if you can check here, what is the angle here? This one forms a right angle triangle, that's 90 degrees. In other words, this 90 degrees plus this angle x here gives us 125 degrees. Now to calculate angle x, we need to say 90 degrees plus x is equals to 125. So for x, we're going to have x is equals to 125 degrees minus 90 degrees. Now we have 35 degrees. This is the angle that we're going to use here, 35 degrees. Now let's move along. If we try to draw the vector diagram, we have B here. This is 300 Newton. And when we resolve this, since it's in the fourth quadrant, remember in terms of your horizontal movement, it's going to the left. And in terms of your vertical movement, it's going down. So we have Fx to the right and then Fy down. So it's going to the right, not left. So Fx to the right and Fy downwards. Now remember, we need to calculate the magnitudes of Fx and Fy. So for Fx, remember, it's F cos theta. Now, what is the force that we've been given there? The force is 500 and the angle is 35. So we have Fx is equals to F cos theta. This is 500 cos 35 degrees. You punch that in your calculator. That's 409.58 newtons. Now for your Fy, Fy is F sine theta. So we have 500 sine 35 degrees. Punch that in your calculator. That's 286.79 newtons. Now we have it like that. Let's try to put it in here. So we have 409.58. And for Fy, we have 286.79. Again, if we have to calculate the sum of the horizontal forces, we can see these two forces are not in the same direction. So they have to subtract. We choose this one as the positive side and this one as the negative side. Now we can only see for the Fy, we have one force, so it's not going to add or subtract to anything. So for the sum of horizontal forces, we have 409.58 plus negative 300. Punch that in your calculator. We have 109.58 newtons. Now the sum of your vertical forces, because we only have one vertical force, is just 286.79. Now that we have the two, we can now use it to calculate our F net. So it goes F net is equals to Fx squared plus Fy squared. What's your Fx? 109.58. 109.58 square, and plus, what's your Fy? It's 286.79. Square. Then you grab your calculator, punch that in your calculator. 109.58 square plus 286.79 square. Then your answer is 307.01 Newton. And that's how you solve these questions. Awesome.